Well, first off, thank you everyone for attending. It's great to see a crowd here, and I really appreciate your time. My name's Neil Hodnett, and I'm the Global Business Development Manager with Haskel, focused on hydrogen. Haskel specializes in compression technology and equipment, and we've been compressing hydrogen for roughly 60 plus years, so certainly a legacy there. The theme of today is to talk about some compression strategies when you're producing green hydrogen. And my goal today is to really show some real-world insights and experience, things I've heard directly from customers over and over again, with the goal of adding value to everyone in this room, whether you're involved with electrolyzers, whether you're equipment vendors, whether you're a project developer. That's really my goal here, and I hope it's a value add. Quickly, I just want to go over how I'm defining green H2. I know this is a very international group of people. The way I'm defining it, just for the scope of this presentation, is focused on wind and solar. I certainly know there's other methods of producing hydrogen, whether that's geothermal, whether that's biomass, which is also considered green. But for the scope of this presentation, it's really on solar and wind, because those certainly have unique challenges, which I'm going to cover on the slides. Also, you can just see some common green H2 production methods, which is most likely going to be electrolysis, and there's a lot of great vendors here that you can talk to and learn more about the different kinds. So this slide is going to cover gas compression challenges. And my goal here is to really try to share some experiences when you're talking to vendors. These are the kind of questions you want to bring up. This is the information that's really going to be relevant. And the first one is being start-stop operation. When you're dealing with green H2, it's probably going to be an intermittent power source, whether that's coming from windmills, whether that's coming from a solar farm. So you want to have a compressor that can certainly start and stop. And you want to validate that they can sustain that, because there's going to be some wear and tear. Also, you want to be able to have a compressor that can match the fluctuation of the renewable power source, right? It might be ramping up, it might be ramping down. So those are questions you're going to want to bring up when you're talking to a vendor. And that's also connected to load following. Secondly, it's involving off-grid use cases. This could be for military customers, this could be for high-level corporate partners. And what that essentially means is that it's completely off-grid. It's relying on a renewable power source, whether that's solar, and it's powering probably a mission-critical operation. And what you want to ask about is the maintenance intervals. How often do I have to change the seals? What kind of labor is involved with the maintenance? How much time, how much resources? Because the last thing you want is to have unexpected downtime for a system that's off-grid, because it's going to be completely shut down. That may cost you money, that may cost you other things. So definitely keep that in mind. Thirdly, cost sensitivity. As we all know, a lot of these green H2 projects are publicly funded, and they may have rigid requirements. So you definitely want to be conscientious of how the vendor is proposing the quote. And I'll talk a little bit more about this on the next slide, a possible solution. And also connected to cost, OpEx, what is the efficiency of this compressor? How much power is involved in allowing this compressor to work? Because especially when it's renewable energy, that may be expensive. So you want a very efficient compressor. Then lastly is the pressure range. You want to be looking at what is the range of the compressor, because when you're dealing with green H2, it's coming off an electrolyzer, and they may want to go up to 500 bar. They may want to go up to 700 bar. They may even want to go up to 1,000 bar. So you really want to dig into what is the range of this compressor model. And the reason why that's a challenge is because it can be quite vast. And here are some strategies to be able to combat those challenges. First off, start-stop operation. You certainly want to validate with the compressor vendor, how does your compressor hold up with start-stop? How is the reliability? How does that affect maintenance? Also, you want to talk about load following. Can the compressor handle fluctuations in output due to the renewable power source? And in my opinion, the market solutions that are currently available that best handle this are a hydraulic gas compressor and then electro-servo-driven gas compressor. I'll talk a little bit more about these on the next slide, but that is my opinion for the best possible solutions. The second challenge that you can combat is off-grid use cases. Again, you don't want unexpected downtime, you don't want heavy maintenance, you don't want a lot of labor involved in keeping that up and running. So you want to be asking the vendor, what are the maintenance intervals? What's the seal life? How do your seals handle purity of hydrogen? Is there any contamination? These are the questions that you really want to drill down into and get clear answers. And again, in my opinion, the two kind of current market solutions that can combat this are a hydraulic-driven gas compressor and then the electro-servo drive gas compressor, which I'll talk about on the coming slides. Then thirdly is cost sensitivity. I think this might be the most important aspect for project execution. You want to avoid wasted CapEx and OpEx by taking an integrated approach, right? You don't want to have the electrolyzer and then you have the compression, the storage, everything siloed. You want to balance a plant. You want all of these different pieces working together instead of more of a siloed approach, which may result in maybe you're oversizing equipment. Maybe it's not as efficient, which is going to cause a higher OpEx. And then in addition, CapEx is the same way. If you're taking an integrated approach, you'll be working with a vendor who will be able to provide you with all of the equipment that you need instead of having to go to maybe 10 to 15 different vendors. Then lastly is the pressure range. You want a compressor that can most likely go up to 1,000 bar. It depends on what your use case is. Maybe it's 500 bar, but you certainly want that flexibility because your off-takers, maybe their needs will change, or maybe you'll find a different off-taker that needs that flexibility. And again, the market solutions, you're looking at hydraulic, you're looking at electric, and then I also included a diaphragm compressor. I think they do have a good flexibility and range. Some up to 500 bar, maybe some up to higher pressures. And just to kind of give you a quick overview on what I mean by a hydraulic gas-driven compressor, that's a compressor that's powered by high-pressure hydraulic oil. It's been on the market for quite some time. You can see a picture of what Haskel offers. This is our integrated solution. But some kind of key, I would say, attributes for green H2 production from this kind of compressor is, one is the small footprint, right? If you're designing a facility, you don't want to have a massive footprint, whether that's permitting, whether that's a cost, whether that's using land. So I'd say having a small footprint is critical for green H2. Also the start-stop, I keep bringing that up, but that's absolutely critical. A lot of compressors will break down if you're constantly starting and stopping. Luckily, this compressor can handle that. Also gas purity, you want to ensure that you're having maybe in some cases fuel grade quality. You don't want any contamination. That's certainly going to cause a lot of downtime and probably anger your off-takers if you can't provide clean hydrogen. So that's something you certainly want to consider. Then lastly is the adjustable cycle rate and load following. Again, with green H2, that may fluctuate, depending on the renewable power source. So you certainly want to consider that. This is the second kind of compressor that I mentioned. This is relatively novel to the market, at least at this scale. This is an electro-servo drive gas compressor. If you do have more questions, our booth is actually right behind the stage. But this is essentially taking the best attributes of the hydraulic gas compressor and maximizing it. Whether that's efficiency, whether that's footprint, whether that's start-stop at any time, whether that's maintenance, because again, you're not dealing with hydraulics, you're dealing with an electric motor. So it's definitely a different maintenance schedule. It's definitely a lower level of labor involved in maintaining the system for reliability. And again, after this, or if you guys have any questions, certainly happy to answer it about this system. And then thirdly, I brought this up on kind of a strategy to combat some of the challenges with green H2 production. I personally think this may be the most important. I've talked to so many customers who are very excited about producing hydrogen. Maybe they have an electrolyzer and they're just kind of getting stuck on how do I fulfill the full value chain. And how Haskel approaches it is we identify world-class H2 integrators that we partner with, and I highly suggest finding an integrator that kind of fits this criteria. And some of the questions you want to ask, what are their engineering capabilities? Are they actually building these systems, or are they outsourcing it? Are they just putting the pieces together, or do they have the capabilities to provide you with a custom solution? Also, track record with customers. Who have they worked with? What countries, what regions? Do they have examples of what they actually built? Definitely something you want to ask. Lastly, this is something that maybe most people don't think of, but what are their supplier relationships, right? Do they have relationships with storage, chillers, compressors, dispensing? That's very critical. Instead of having to go to all of these different vendors, I would suggest finding an integrator who can put the full piece together. Again, the whole hydrogen value chain. And also strategic partnerships, which include electrolyzers. Some of our partners work with some of the electrolyzer companies here, I believe. So just looking for a partner that can provide that whole value chain is absolutely critical for OpEx and CapEx. And you can see in these photos, this is just some examples of one of our integrators that basically showcasing what they have worked on. You can see some military applications, whether that's a microgrid, drone for hydrogen drones, a refueling system, and then also a mobile hydrogen compression, refueling, and storage system. So again, you really want to just dive into and understand what have they built, right? What are their capabilities? Again, are they just putting the pieces together, or can they provide you with a custom solution? And lastly, I wanted to go over kind of a small case study, just demonstrating the most extreme example for Green H2. This is a customer that we worked with through an integrator. It was the United States Air Force for an off-grid deployment in Hawaii. And the reason I bring this up is because it was for a critical military application where they couldn't afford any unexpected downtime. They needed reliability, they needed a predictive maintenance schedule. They also needed to train someone to keep it going, so they needed low labor. They didn't need any complicated tools trying to keep this system running. And they decided to go with a hydraulic-driven gas booster for those reasons. They specifically went with Haskel for those reasons as well. And I just wanted to highlight this to show even in the extreme cases, customers are going for a hydraulic gas-driven gas booster, a hydraulic gas-driven booster. And in this case, they went with Haskel. And this concludes my presentation. I hope it was very informative. I hope you guys got some insights. And we're right across, our booth's right over there. We'd love to talk to you, answer any questions. I think that's about it, unless anyone has a question. If not, we can conclude the session. Any questions? I know it's right before lunch, so maybe everyone's a little hungry, so. Okay, well, thank you for your time. I really appreciate it. Thank you.